Hi, I'm going to solve the problem number 4 from exercise in the section 8. And here you have the problem. So, an investor has an amount of $150,000 and he can invest in two types of investments. ABX, that is with a minimum amount of 10,000, expected return of 12%, and the risk level of 0.5. And the second investment is BZT with a minimum amount of 15,000, expected return of 10%, risk level of 0.2. The investor would like to maximize expected average yield and minimize the average risk. One option is not to expend the whole amount of money, and this is the table with the results. So the first question is what formula should be in cell B10. So let's analyze the table to see what happens in this table. So I have data, expected return. I have two products, ABX, BZT. I expect the return, the risk. Until here I have the data. So I'm defining variables. I have that variable here and that variable, which has to be, for example, the amount of money invested for each of investment available for us, and amount investment. This is going to be the variables. We have values here because there is a solution here. Okay, so minimum amount, this is a kind of constraint. And we have two objectives. Average return, that value here, and average risk, that value here. Okay, so let's see the questions. In cell B10, that one, what formula should be in that cell? So an easy way to do that is just, okay, let's take that formula here. If I calculate the product between B2C2 and B6C6, it means I'm going to calculate this times 10 plus 10% times 140,000. If I calculate that, I will not get that value here. And I can do it, for example, just calculate the value for this, and the last one, and I'm going to see the last one is the answer. So, another way, another way to discover that value is just make the average, and the average is going to be exactly 0.1013.3. Okay, so same idea I can do for the second question. Okay, so question 3. What among the constraints referring to cells B6C6, which one should be in the solver window? And so I'm looking for a constraint involving the variables. The variables is in these cells. One constraint among that list that should be in solver is that one. Let's see what this represents. B6 greater than B7. So BC is that one, the variable. Greater than B7, it means the variable has to be at least the minimum amount. So this is a constraint, and this is the answer. Okay, for question number 4, what cells should be indicated as variable cells? So the variable cells are these, B6 to C6. They are the variables. These cells are you put in the solver as variables. You know, when I click, for example, here in the solver, here I will put B6 until C6. Okay, so question number 5, and for that question is a little bit nice. I have 2 targets. The target is my objectives, my goals, and and these are my targets. The average return, which we want it to be the maximal one, and the average risk, which should be the minimal one. So this is going to be my targets. I have 2 targets. And if we have a look here at that solution here, when we make optimization, we can have only one objective function. So I can put average return as objective function, or I can put average risk as objective function. I cannot put both of them. For example, I could have something like that. Maximize the return and constraints. And for the first one, that one, I don't care about risk. I could have that one, minimize risk, constraints. The constraints of the model, for example, minimum amount of money. And that is it. In that case, I don't care about return. I could have that one. I maximize return, and my risk have to be lower than something. And constraints, the previous constraints I had in the model. So in that case, giving a B, and we are going to change it at each time I need to solve the problem, you get the maximal return. And the last option, I could have minimize risk and return equals to C and constraints. So that one is the last model possible for that case. So in your case, for example, I can think this as constraint, you know. For example, if I consider that case here, maximize return risk has to be a constraint. It could be framed in this. So I maximize the return, I get this as objective function value, and this is a kind of constraint. So for answer 5, what cells acts as target value when solving this multi-objective problem with the solver? The answer for that exercise is given as this, B10 and B11. Both of them are targets. However, when you are solving using solving the problem using the Excel solver, we can have only one objective function. And I would say the cells that act as the target is only B10. Okay, so let's see question 6. So question 6, the solution presented in the spreadsheet indicates one of the solutions used to obtain the Pareto curve for this problem. What version of the problem has been solved? answer the question with this. We are solving, for example, that one, which makes sense, and maximize the return and the risk is a constraint. And that is exactly what is said in letter C. I maximize B10, which is the return, adding the constraint B11 lower or equal C11, and B11 is the risk, and C11 is exactly the B I put here. Let's read that. So for each of the following statements, say if they are true or false by setting your choice. Let's consider the following 5 solutions to the investor. So for this kind of question, we can first of all draw a graphics to help us. Okay, so let's draw a graphic with the objective function as axis. So this is going to be, for example, return. This is going to be risk. And I will put these points, this point here, in the graphic. Why? Because I'm selecting the objectives. Okay, so I have one point here, and this is going to be the point number 1. I have one point here. This is going to be number 4. I have one point here. Going to be number 2, point number 2. I have one here. Given I have these graphics right now, it's more easy to answer these questions. The first statement is the following: solution 5 is strictly better than all others. And let's see that in the graphics. Solution 5 is that one. Okay, here. That point is not better than 3 because the return of 3 is bigger than the return of 5. So this is false. Solution 1 dominates solution 2. It means when I say solution 1 dominates solution 2, I'm saying solution 1 is better than solution 2. Let's see if that is true. Solution 1 have a lower return compared to the solution 2. So, only seeing this, solution 1 is not better than solution 2. And the statement is false. Solution 1 through and 5 are not dominated. Let's see that. Okay, for solution number 1, solution number 1 has the best risk, the minimum one. So solution 1 is not dominated. Let's see solution number 3. Solution number 3 has the best return. So solution 3 is not dominated. And the other one is solution 5. Solution 5 for example, if we compare with solution 3, solution 5 has a lower return than solution 3, however, has a lower risk than solution 3. So I cannot compare 5 and 3. There is no domination relationship between them. Let's compare with solution 2, 5 and 2. 5 has a better return, however 5 has also more risk. So I cannot compare solution 5 and 2 in such a way to say one of them is better. There is no dominance relationship between them. So, if I do this analysis with 5 and 1 or with 5 and 4, I can say 5 is not dominated. So, statement C is true. Let's see the last one. Solution 4 is dominated by solution number 1. So I have solution number 1 here. It has a better return than solution 4. And it has a better risk than solution 4. It means solution 1 is better than solution 4. So it means solution 1 dominates solution 4. And the statement is true. Okay. And I'm going to make an additional question. What is the Pareto front in that problem? And the answer is the Pareto front are composed by non-dominated points. We have seen 4 is dominated, so 4 is not inside the set of points belonging to the Pareto set. So 4 is not, and the Pareto front is going to be something like that. These points 1, 2, 3, and 5 are among the points of the Pareto front.